we're asked to find what is the new period of rotation. So because there is no external torque or force being acted upon by the system, we know that Li is equal to Lf, and these are just the two angular momentums of the star before and after the contraction. We should also know that the angular momentum of a sphere can be written as 2/5 times its mass times its radius squared. And also we're going to need to use the formula omega is equal to 2 pi over the period. Okay, so L, this is I. Oops. Okay, so L can also be written as the moment of inertia times its angular velocity. So we'll write I initial times omega initial is equal to I final times omega final. And now for I and omega, we're going to plug in these values. So I is going to be 2/5 m times the initial radius, we're going to denote that by just r sub I squared, times 2 pi over the initial time period, and that's equal to 2/5, the same mass because the mass of the star isn't necessarily changing, it's just contracting, so it has a new density but the same mass. So now we'll have a new radius of r final squared, and then omega final we'll just rewrite as 2 pi over the final period. Okay, so from here a couple things are going to cancel. First, the coefficients of 2/5. Masses are going to cancel because it's being held constant, and also the 2 pi. So from here we're just going to solve for TF. So we just have Ri squared over Rf squared is equal to 1 over Tf. There's also a Ti down here. And then just to flip that fraction around, we have Tf is equal to Rf squared Ti divided by the initial radius squared. And to plug in values for that, it's important to note that the radiuses and the period, based on the units you plug them in, we're going to be using 25 days in seconds because the new period of rotation is going to be really small. To express that in seconds is going to be much more useful. So just note that this Ti is going to be 25 days, which is equal to 2.16 times 10 to the 6th seconds. And that's Ti. Okay, and then from here we're just going to get 0.011 seconds. And that is the period of rotation of the neutron star after it's collapsed.